Let's look at the following example. A candle burns at a constant rate of 1.8 inches per hour. 5.6 hours after being lit, the candle is 9.92 inches tall. The candle burns continuously until it is completely consumed. We'll let the variable h represent the candle's height in inches, and we'll let t represent the elapsed time in hours since the candle was lit. So just reading this statement, we can actually kind of imagine what's going on here. So maybe we have a candle, and this is my doodle of a candle, and when t equals 5.6, or 5.6 hours after it was lit, the candle's height is 9.92 inches, so h equals 9.92. Now, since the candle burns at a constant rate of 1.8 inches per hour, each hour that passes, the height of the candle is actually decreasing. So each hour that passes, the height decreases by 1.8 inches. Or, for any change in the number of hours since the candle was lit, the height changes by negative 1.8 times as much as the change in time. So, the ratio of delta H to delta T is not 1.8, but actually negative 1.8. And this is because as T increases, H decreases. And since this ratio of the change in height to change in time is equal to negative 1.8, that tells us that the change in height is always negative 1.8 times as large as the change in time. And using the information they gave to us, that when 5.6 hours have elapsed, the height is 9.92 inches, our reference point for this problem description is actually 5.6, 9.92. Now, you could type those values into MathAS, and it should accept it as correct. Now, what we can do is we can actually decide how long the candle is some number of hours after it was lit. So, for example, we'll look at this first question. So, 11.1 hours after the candle was lit, we'll decide how tall the candle is, or what the height of the candle is. And 11.1 hours after it was lit, T is equal to 11.1. Now, we can think about this graphically. So if I draw a set of axes, one representing the value of T, and on the vertical representing the value of H, we know a few values. So 5.6 hours after the candle was lit, the candle's height is 9.92 inches. So we've got this reference point. And what we're going to imagine doing is letting the time since the candle was lit increase from 5.6 hours to 11.1 hours. So we increased from 5.6 hours to 11.1 hours. Now, we know that this change in time, so this change in time is equal to 11.1 minus 5.6. And what we know is, since the candle burns at a constant rate of 1.8 inches per hour, the change in height of the candle, delta H, has to be negative 1.8 times as large as that change in time. So this change in height is going to be equal to negative 1.8 times 11.1 minus 5.6. So the height of the candle, 11.1 hours after it was lit, if we look over to the vertical axis where the values of H are represented, we can actually decide what the height is. So the candle started at a height of 9.92 inches, and as T increased from 5.6 to 11.1, the height of this candle decreased by this much. We know what this change in height is. The change in height is whatever this value is over here. So this new value of H, or the height of the candle, 11.1 hours after it was lit, is equal to the initial value, 9.92, plus whatever the change in height was, which was negative 1.8 times 11.1 minus 5.6. So again, the change in time was 11.1 minus 5.6, and iMathAS will compute that value for you. And we know that the change in height has to be negative 1.8 times as large as this value. So the change in height will be whatever this value is. We know that the new height, or the height of the candle 11.1 hours after it was lit, is equal to the initial height plus whatever this change in height was. Now we can always use this way of thinking to determine how tall the candle is given any value of t, or given any number of hours since the candle was lit.